continuing on your guys' review. So, for number 9, we have to determine if are these triangles similar, and if so, why. So, remember, you guys have 3 similarity statements, and we have to see if any of these are similar from those 3. So let's take a look at A. Well, one triangle is 50 and 30 degrees and the other one's 150. So we have to figure out if this triangle possibly has 2 angles that are congruent. Well, we know a triangle adds up to 180. So if that's 50 and 30, you guys, that's 80, which means this one has to be 100 degrees. For this triangle, if one angle is 100 and one angle is 50, that's 150. So the triangle always adds up to 180 for the interior angles. So that has to be 30. So you guys, when you take a look at these triangles, I noticed that we have 2 pairs of congruent angles, which means these triangles are similar by the angle-angle similarities theorem. So yes, they are similar because we have 2 angles, 2 different sets of angles that are congruent to each other. Part B. So I at least know that this angle is congruent to this angle, right? Now, what about the sides? Well, we should see if they're proportional. So 10 over 5, does that equal to 8 over 4? 10 over 5 is 2, 8 over 4 is 2. So yes, this side is proportional to this side, and this side is proportional to this side. So are these triangles similar? Yes, because of side angle side similarity theorem. We have 2 sides proportional, 2 sets of sides proportional, and we have a pair of angles congruent, and the angle is in between the 2 sides. Part C. So I'm kind of thinking to use side, side, side possibly, you guys, because we have 3 different sides for both triangles respectively. So let's see if we can make a proportion. 20 over 4, is that equal to 30 over 6? And is that equal to 40 over 8? Well, all of these are equal to 5. So this side's proportional to this side's proportional to this side's proportional to this side. So are these triangles similar? Yes. By side, side, side similarity theorem. Okay, part D. Now, 2 over 4, does that equal to 1 over 2? 1/2 certainly equals to 1/2, so we know the sides are proportional. But take a look, you guys. This angle is congruent to that angle, right? So this is something you guys should notice. This angle is not included between these 2 sides. It's not in between these 2 sides, and that's the only way we can prove triangle similar if it's an included angle of side angle side. So this one is no, not similar. Because this angle, you guys, is not in between the 2 sides. If it was, then yes, these triangles would be similar, but it's not. Alright, so we have the similar triangle theorems. So when you guys see problems such as 10 and 11, you guys just make a proportion because we have similar triangles. So for this one, 12 over 24, this is not the only way to make a proportion, but this is just a way to make a proportion. I'm gonna cross multiply. It's way too thick. Okay, so 12 times x is 12x is equal to 24 times 18, which is going to give us 432. divide both by 12. X is going to equal to 36. Okay, 11. We can make proportions. So again, you guys can do proportions any way you like, as long as it's consistent. So 3x equals 18 is equal to 5 over 10. Could have chosen 3x over 5 equals 18 over 10. Could have chosen 5 over 3x equals 10 over 18, as long as you guys are consistent. Make a proportion. 3x times 10, you guys, is 30x. 5 times 18 is 90. Divide both by 30. X is equal to 3. Number 12. Okay, so remember, when this segment connects the midpoint of this side and this side, you guys, then this is double of that. So what we can do is we can double 10, you guys, and that's going to equal to this segment. So double 10 is equal to 5x. 20 equals 5x. Divide both by 5. X is going to equal to 4, which makes sense because 4 times 5, you guys, is 20, and 20 is double of 10. Okay, 13. So this one, you guys gotta draw a figure and then make your triangles and then figure out what they're asking, right? So a tree is 24 feet tall. It casts a shadow, which is 12 feet tall. So there's my triangle. Brad is 6 feet tall. How long is his shadow? So you're solving for this, his shadow. Well, since these are similar triangles, you guys make a proportion. So I'm going to do the height of the tree over the tree's shadow is equal to Brad's height and over Brad's shadow. You guys cross multiply. So that's going to be 24 times x, you guys, which is 24x. 6 times 12, you guys, is 72. Divide both sides by 24, and x is going to equal to 3. So Brad's shadow, you guys, is 3 feet long. Brad's shadow is 3 feet long. Okay, simplifying square roots. So when you guys simplify square roots, right, you multiply the coefficients on the outside of the square roots, and you multiply the numbers together on the inside the square roots. So 2 times the 3 is 6. Square root of 10 times 6 is 60. Now we could do a prime factorization tree. 6 and 10, 2 and 3, 2 and 5. So do you see any pairs? Do you see any two numbers that are the same? Well, I certainly do. We have a pair of 2's, right? And a leftover of 3 and 5. So when you guys simplify, please do not forget the 6 that we originally had on the outside, right? So the pair we found was 2, so 2 square root of 3 times 5. Leftovers go on the inside. So 6 times 2, you guys, is 12, square root of 15. Alright, so for 15, we got 4 times 3, you guys, outside numbers, coefficients, which is 12, square root of, now you gotta multiply the two inside numbers inside the square root. 2 times 14, 28. factor 7 and 4, 2 and 2. Got a pairs of 2's, left over of 7, and again, do not forget the 12. So 12, you guys, times the pair we found, which was 2, square root of 7, 24, square root 7. Alright, so 16 and 17, you guys. So I'm going to write my ratios down. Okay. Well, I'll zoom in for this. Okay, so I made my ratios, right? That's the ratios to get from one length to the other. Okay, so this diagonal is the hypotenuse. This corner is always pointing to the hypotenuse, the side opposite of the 90 degrees. So take a look. This is the smaller angle between 30 and 60, right, you guys? So as a result, this is the short leg. And this would be the long leg. Now, we have information at the long leg. So, long leg, you guys, to short leg, we gotta divide by the square root of 3. So, 3 divided by the square root of 3. Now remember, you cannot have a square root on the bottom, so to get rid of that, you need to multiply top and bottom by that same square root. 3 times square root of 3, you guys, is 3 radical 3. So square root of 3 times square root of 3, you guys, is square root of 9. But you guys know the square root of 9 is just 3. So, you can't divide that square root of 3 by 3, you guys, because, again, it only can be affected by another square root. But this 3 cancels off with that 3. So the only thing we have is square root of 3. And that is going to be the answer of the short leg. Now we need to find the hypotenuse. To get from short leg to hypotenuse, that is multiplying it by 2. So 2 times square root of 3, you guys, is just 2 square root 3. Gotta make sure you guys know how to get from one length to the other using your ratios. Okay, 17. Hypotenuse to a leg, you guys, is dividing by square root of 2, and from a leg to hypotenuse, multiply by square root of 2. So let's label. Again, side opposite of the 90 degrees, or the diagonal, right? That's the hypotenuse, which means the other two, you guys, are just the legs. Both legs are the same because both of the angles are the same. So we have the hypotenuse, now we just gotta find the leg. So from hypotenuse to leg, you guys, hypotenuse to leg, you gotta divide by the square root of 2. But again, you cannot have a square root on the bottom, so to get rid of it, you gotta multiply top and bottom by that same square root. 10 times square root of 2, you guys, is just 10 rad 2. Square root of 2 times square root of 2, you guys, is square root of 4. But square root of 4, you guys, is just a perfect 2. Now I'll simplify this fraction. 10 divided by 2, you guys, is 5 square root 2. So this is 5 square root of 2, you guys, and if that leg's 5 square root of 2, that means this other leg's also 5 square root of 2. Okay, so last problem. Okay, you guys gotta solve for x, y, and z. So now it's always wise to make your guys' triangles so that you could kind of visually see the 3 different triangles that we're dealing with, right? Okay. So, my suggestion is when you guys solve for each one of these, go one at a time and cover up the other two variables so that you know which ones to solve for. So, I'm going to cover up like I don't see that one and I don't see that one. So how would you solve for x? Which two triangles would you guys be comparing to use to make a proportion? Well, I know x is here and it's here, right? It's there. This length would be 4, you guys. This length, you guys, would be 4 plus 5, which is 9, right? So I know to compare those triangles, you guys. And if we were to label these, this is the hypotenuse, this is the short side for that triangle, this is the hypotenuse, and this is the short side for that triangle. So to make a proportion for our first one, I'm going to do 4 over x, which is short side over hypotenuse, is equal to x over 9. For the short side and hypotenuse for that other triangle. Then from here, you guys, it's just cross multiplication. X to the second power, because that's x times x, right? 4 times 9 is 36. So to solve for x, you guys, you gotta square root both sides. X equals, well, you guys might have to do a prime factorization tree if you don't realize this, but what's the square root of 36? It's a perfect square. It's 6. So we got 1. We got one of our answers. Now, I'm going to cover up x and z so that I can target this next one, which is y. Okay, so where is all this information in respective to these triangles? Well, y is right here, y is also right there, this length is 4 and this length is 5. So, I know to use these two triangles to make a proportion. So, in your notes, right, I also wrote this to you guys in your notes, this side is the short side, this side is the short side, this side is the long side, this side is the long side for the respective triangles. So let's make a proportion. I'm just going to do 4 over y, so short side over long side. And now again, you do not always have to do short side over long side, as long as you guys are consistent with making your proportion. So you could have done long side over short side, that's fine. But for the other triangle, you better do long side over short side then. As long as you guys are consistent. Top to bottom, top to bottom. So short side to long side over here, you guys, is y over 5. Now here's a trick, you guys, if you know you're making your proportions correctly. Do you guys well, actually, I will say that at the very end. So now we cross multiply, you guys, so that we can solve for y. Y times y is y to the second. 4 times 20 is 20. Sorry, 4 times 5 is 20. Square root both sides. So that's y. Now, the square root of 20, you guys, we gotta do a tree. Because there is no perfect... that is not a perfect square. Pairs of 2's. Leftover of 5, so 2 is on the outside and the leftover is on the inside. So y is equal to 2 square root of 5. Okay. So last one. I'm gonna erase all this stuff, you guys. So cover up this because this is just a distraction for you guys, right? So let's see. So if we're trying to solve for z, you guys, we know z is right here. We know 5 is right here. Z is also right there. This whole length, you guys, again, it's not 5, it's not 4, it's a combination of both, which is 9. So when you guys get to labeling, which is also in your notes, right? This is the hypotenuse, this is the long side, this is the hypotenuse, this is the long side. So when we make a proportion, I'm going to show you guys, you can set it up however you guys want, so I'm going to do hypotenuse over long side this time, as opposed to the first time we solved for x. And then for the other triangle, it better be hypotenuse over the long side. You guys cross multiply. Z times z is z to the second. 9 times 5 is 45. Square root both sides so you guys can eliminate the second power. Now for 45 guys, you gotta make a prime factorization tree. There is no perfect square for 45. 9 and 5, 3 and 3. Found a pairs of 3s, left over a 5. So as a result, the pair we found was 3, square root of 5. Now here's the trick. Here's the trick how you guys know you are doing the similar triangles correctly when you guys are making your proportion. Anytime you guys set up your proportions correctly, do you guys notice that one diagonal is going to be the same? One diagonal is going to be the same. So when you guys cross multiply, one of the diagonals better be something times itself. X times x, x to the second, y times y, y to the second, z times z is z to the second. If that did not make sense to you, then don't worry about it. So that's your guys' review. Make sure you guys study up and good luck, okay? Peace.